let's say f of x is a continuous function and non-negative. We define R as the region bounded by the graph of f of x, below by the x-axis, on the left by the line x equal a, and on the right by the line x equal b. Then what would happen? Say here is our graph. And say here's our f of x. Is bounded below by the x-axis, the left by the line x equal a, the right by the line x equal b, and we have this is the region. Let's say if we then rotate in this figure around the x-axis, if we rotate in this about the x-axis, then we will get this figure. Okay. And as you can see here, the cross section are circle, right? And so then the area of the cross section will be the area of the circle with the radius being f of x, So then the cross section are circle. Okay. The area is equal pi times r squared. That is pi. The radius is f of x squared. So then we integrate in this from a to b of pi r squared, which is f of x squared dx. Okay. So, in general, we can rotate in this cross section about the x-axis or about the y-axis. It depends on the question. If we rotate in this about the y-axis, then we will integrate this with respect to y. Okay. So let's take a look at an example. The region between the curve f of x equal x squared minus 4x plus 5, that is between x equal 1 and x equal 4, revolve about the x-axis to generate the solid. Let's find the volume. Yeah. Let's first take a look at what the graph of f of x look like. Okay, so let's take a look at the graph of the curve. X squared minus 4x plus 5. So this is the curve. Okay, so let's put this onto our paper. So we know that this point over here is 4, 5. Okay, so let's go ahead and sketch our graphs. So this here have the vertex at 0, at 1, 2, and then between 5 to 4. Okay, so let's put this in a graph. So we have this point on the graph was 0, 5, and this point over here was 4, 5, and the parabola looked like this. Okay, and it bounded by this by x equal 1, and x equal 4. Okay, so this is the region that we were looking at, then we rotate this about the x-axis. Okay, so that is the figure. Then the radius of the cross section is f of x. So then the volume of the solid is integrating from 1 to 4 of pi r squared, that is f of x, that is x squared minus 4x plus 5 squared dx. What we need to do is to expand x squared minus 4x plus 5. Okay, so assign. Let's take a look what is x squared minus 4x plus 5 squared get us. So expand this out, x squared minus 4x plus 5 times x squared minus 4x plus 5 equal x to the 4 minus 8x to the third plus 26x squared minus 40x plus 25. Back to our volume. So this is the volume between a pi integral from 1 to 4 of x to the 4 minus 8x to the third plus 26x squared minus 40x plus 25 dx. This is pi 1/5 x to the 5th minus 2x to the 4 plus 26 over 3x to the third minus 20x squared plus 25x. Evaluate from 1 to 4. This equals 78 pi over 5. So we look at the solid revolve about the x-axis to create the solid, right? So what happens if we revolve about a different line, right? So let's take a look at this example. The volume of the solid generated by revolving the region bounded by y equals square root of x, and the line y equal 1, x equal 4, about the line y equal 1. So let's sketch this figure. So y equal to square root of x. Let's go through 1. When x equal 4, y equal 2. And this is not to scale. So this is y equal root x, bounded by the line y equal 1 and x equal 4. And this is the region that being rotated. Okay, so when we rotate in this, you get this figure. Okay. Right. So first of all, we'll find the intersection of y equals square root of x and y equal 1. So that intersection is at x equal 1. The area of the cross section so this here is the radius of the cross section. Okay. So that is the radius. The radius is the difference of y equals square root of x and y equal 1. So area is equal pi times the radius square root of x minus 1 square, and then the volume. The volume V is between 1 to 4 of the area, that is pi square root x minus 1 square dx. So let's simplify. Let's expand this out. Okay. Integrating that and evaluate the integral between 1 to 4, we get 7 pi over 6. Next example. Find the volume of the solid generated by revolving the region between the y-axis, bounded between the y-axis, the curve f of x equal 2 over x, where y is between 1 to 4 about the y-axis. Okay. So let's draw this. So 2 over x is this curve, look like that. It's bounded by y equal 1 and y equal 4. So this is the region that been revolving. And we will revolve it about the y-axis to get this solid. Note that the cross section now is the circle, the radius f of x equal 2 over x. And since we rotating this about the y-axis, it is better to integrate with respect to y, right? So first of all, start with y equal 2 over x. We solve this function in terms of y. X equal 2 over y. This is our radius. Okay, so the volume is equal pi, that is bounded between 1 to 4 of radius square 2 over y square dy. So this is 4 pi from 1 to 4, the y to the negative 2 dy. 4 pi times 1 over y. Evaluate from 1 to 4. That is 3 pi.